Hi, welcome to another tutorial from Mathematica. Today we are going to learn how to do plotting. I'm just going to give you some brief ideas how to plot, how to uh, play around with it. So I'm just going to do on 2D plotting. There is 3D plotting also available in Mathematica, but I'm just going to focus on 2D. So to start off with, the plot function is called as its plot. So I'm just gonna keep this over here, the help menu, just for that we can cross-reference it. So in this one there is two things which I'm going to focus on. One is plot with one function and plotting with several functions. So it's just basically you plot and then you open the square brackets, and then you have the function, and then you have the range of the function from if it is x squared, so you want to define the range from x to x min, that is a range to maximum range. Yeah, so let us look at this equation y equal to x squared. So what we have is right now we need to plot for x squared. So it's going to be, we're going to have the plot function, the name. So like what you can see plot, and then see for plotting 2D it's just plot, and for plotting 3D you have to write plot 3D. Plot 3D is very colorful and it looks really good, but I'm just going to show you how the plot 2D works. So in this right now I have y equal to x squared. So my function is x squared, and then I'm opening the curly brackets to define the x ranging from, there should be a maximum to minimum. So supposedly I'm going to keep like from -4 to +4. Yeah, so I'm closing all the bracket and then shift enter. There you get a plot. So this is 2D plotting, what I'm talking about. It is useful for you in many other for graphing and things like that, which might be useful for you guys. So I want to show you different types of plotting. So this is one way, this is one type of plotting, and for example, now I have more than one function. So for example, I have this line y equal to x squared, and I want to plot another y equal to maybe x plus 4, and then I want to plot for sin x. Yeah, so I'm just gonna close it, and then so how it's gonna work, it's gonna be plot. So I'm opening, oops, so this is how it is. So you have plot and then one function. The first function I'm going to write in curly brackets is x squared, comma, I'm going to write x plus 4, comma, sin x, sin x. So make sure your sin s is capital and your x is written inside the square brackets. So my range I'm going to put from x, it's ranging from maybe -4 to 4 again. Let's see how the plot looks like. Oh, oops, I forgot to close the curly brackets here. That's the reason why there was an error. So in this you can see there is 3 different lines. So this line is for x squared. This parabola kind of stuff is for x squared. This line is x plus 4, and this kind of a sinusoidal wave is what is called for sin x. So this is how you combine all the 3 functions into one plot. So this is how we plot in 2D. So I'm just going to recap on this. So you have a line, maybe a parabolic line where it says y equal to x squared, and then you plot first, put the function name, and then you open the square brackets, you put x squared, that is this function, and then you um, then you specify the range that is then you specify the range of x, which is -4 to 4. It depends on your problem. Yeah, and you get this particular curve. And then for if you have multiple functions, y is equal to multiple functions, and you want to plot everything in one graph. So this is how you do it. For that you put the plot function, open the curly brackets, and list down all the functions, that is x squared, x plus 4, and sin x, all separated by commas. You close the curly brackets, and then you specify the range, and you get it. So next, what I'm going to discuss is on how to label the x and y axis. So it's pretty simple. So for example, I'm just going to use the same problems, and once I close this curly brackets, I'm going to put a comma. So we're going to use the function called axis label. Yeah, and then you have arrows given, and then you open the curly brackets, you put x, and you want y of x. So I'm just putting all this in quotes, and then I'm closing the curly brackets, and I'm closing the square bracket. So make sure you write all this in one in the plot function itself, and then you press Shift Enter. Okay, this is for the previous one and this one. There you go. Your y-axis, it's y of x, and your x-axis is x. So I want you all to try out this problem. F of t is equal to t cos theta, t cos t, and t is ranging from 0 to 4 pi. I want you all to pause the video. I want you all to plot it, and then label the axis, and pause the video and come back. Alright, so how we're going to do is, it's pretty simple plot. We're going to write t multiplication cos capital C and t. Alright, and then comma. My range is t from 0 to 4 pi. Close the range. Okay. Okay, it's not done. I won't name the label, axis label, and it should be from t comma f of t. This should be in apostrophe, shift enter, and then close, shift enter. So this is another one. All right, ignore this. So this is the type of graph which I was talking about. So I hope you all got this. So now I want to go beyond the scope, and I want to show you how to play around with it. So if you want to beautify, or you want to change into different color. So for example, there's a command called plot style. All right. So in plot style, over here you can define the color of the line. Maybe I want orange. Yeah. If I press Shift Enter, let's see what I'm going to get. Look, I'm going to get an orange color. Oops. I'm going to press Shift Enter again, sorry. So I'm getting an orange color over here. Yeah. Suppose I want to I want this line to be dashed. Alright, and then I'm pressing Shift Enter. There you go. Earlier my line was straight, there was no dash in it. Now it's dashed, and again now I want to increase the thickness. All right, so to maybe 0.02 or 0.04. All right, and let's see how it changes. There you go. This is how it will look if you increase to 0.04. That's pretty big, I suppose. Maybe 0.02. Shift Enter. Oh, much better. Yeah, so you can play around with this however you want. So this is just a demonstration of how to plot, and then the next thing what I like to show is how there's a command called plot range, and for example, for that I'm gonna use plot x squared comma, opening the curly bracket, x minus 3 comma 3, and then closing the curly brackets. So plot range, what the plot range really does is you can click plot range and define it as all. Yeah, and let me see what our answer is going to be. Shift enter. Oh, this is another one. So this is the range what you have. Okay, all plot when you do plot range. I can be more specific in plot range. Let's see. This is when you do plot range all. Okay, so it's correctly graphed and it's properly in range. So for example, I want to change this all to open curly brackets minus 3 comma 3 and then comma. I want the range of this is for the x-axis. I want the range of the y-axis to be from -2 to 9. All right. So, and I close the curly brackets. I close the curly brackets, and I press Shift Enter. Let's see how it looks. So, what happened over here right now is so what you notice over here is the range -3 to 3. So the x-axis has -3 to 3, and your y-axis is ranging from -2 to 9. You can change it if I want -4 to +4. Shift enter, and there you get your answer. -4 to +4. So at times you will have to manipulate the ranges by manually in order to get the graph, and it looks much more neater in this. Or maybe I can just add like 12 or 10. So Shift enter. If you look at this, it stops at 9 over here, +4 minus 4. So I'm just going to give you a recap on everything what I said. So first itself, let me come to the main thing. So plot, when you have generates a plot of f as a function of x from x min to x max. So this is the command. Anytime you can come to the help button and search for plot and see what are the different functions that's available. And then, for example, for plot in our problem, we write the function. Our function is x squared, and then you write the limit, and then you press Shift Enter, you get the plot. The second is when you have multiple functions that you want to plot in one single graph, that you write it in curly brackets. So it's kind of like a list of functions. So if you remember and recollect in the first tutorial what we learned of why curly brackets we use, it's to define the set number of list. So in this we have like 3 or 4 or how many of lines you want to plot in one graph. You can just list down all the functions and then define the range, and once you plot it, you get this kind of a plot. The next step is the next one is I introduced you about axis label. This is to label the different axes x, y, and z. Oh, sorry, this is another graph. So x and y axis. So this is how you plot it, and once you generate this, you will get this graph. So you have your labels generated over here on the axis. The next one I talked about was about plot style. So why we use plot style is just for beautification purpose. For example, see, all this while you will just get a normal blue line when you do the normal without the plot style. But when you do the plot style and change it to orange, or you make the line as dashed or have a thickness, your plot is going to be looking like this. So it can be used when you're comparing two different multiple number of functions, yeah, to differentiate it easily. And then the last concept what we learned about is about plot range. The main function of plot range is to define your x-axis and y-axis length, yeah, just to give a good range to the particular plot. So at times, if you do not define the range properly, you may not get a graph, you may get an error, which I had got a lot of times. So make sure when you do the plot range, you kind of play around with the different ranges on x and y axis to get your graph correct. So now moving on to the common errors. So some common errors I've just listed it down, like saying the first letter should be capital for all functions. So make sure your plot P is always capital, and then plot range. So P and R should be capital. So make sure you write all the functions as capital. I mean with capital letters. Don't miss out anything. Make sure you write the correct command, or else you will get an error. I'm not going to show you what the error looks like because we have already been through all the type of errors, and then using the wrong brackets. So if you use square brackets here instead of curly brackets, it's gonna give you a wrong output. And then using a wrong punctuation mark or missing out commas. So what I mean by that is, like, if you put a semicolon here or you put a colon here and then you miss out, or you miss out this colon, the semicolon over here, and you press shift enter, you get the whole answer wrong. So that's what I meant. So make sure you segregate each and every function and the range, everything with commas, or else you are going to get a function. So I hope you understood how to plot in Mathematica. So this is just a basic and a generic idea, just for you guys to understand what is plotting and how it's done, and different ways in which you can plot. Like multiple or maybe a single function or multiple functions. So I hope you understood this, and thank you.